In this module, you will learn about molecular and ionic solids. On the basis of the type of forces holding the constituent particles together, crystalline solids are broadly classified into molecular solids, ionic solids, metallic solids, and covalent or network solids. Let us begin our discussion with molecular solids. The constituent particles in these type of solids are either atoms or molecules. The atoms or molecules are held together by weak forces of attraction. Further, on the basis of the nature of the intermolecular forces of attraction, molecular solids are divided further into nonpolar molecular solids, polar molecular solids, and hydrogen-bonded molecular solids. Let's discuss each in turn. In nonpolar molecular solids, the constituent particles are either atoms or molecules. The atoms or molecules in these solids are held together by weak dispersion or London forces. As a consequence, these molecules have low melting and boiling points. Hence, most of them are liquids or gases at room temperature and normal atmospheric pressure. For the same reason, they are soft. As the electrons remain localized to particular atoms or bonds, these are non-conductors of electricity. In polar molecular solids, the constituent particles, molecules, are formed by polar covalent bonds. Solid sulfur dioxide and solid hydrochloric acid are some polar molecular solids. The molecules in polar molecular solids are held together by relatively stronger dipole-dipole interactions. As a consequence, these solids have relatively high melting and boiling points. However, these are usually gases or liquids at room temperature and normal atmospheric pressure. Like nonpolar molecular solids, these are also soft and non-conductors of electricity. In hydrogen-bonded molecular solids, like polar molecular solids, the constituent particles, molecules, are formed by polar covalent bonds. However, the bonded atoms in these molecules are essentially hydrogen and a highly electronegative atom, such as fluorine, oxygen, or nitrogen. Ice and solid hydrofluoric acid are two examples of hydrogen-bonded molecular solids. The molecules in these solids are held together by strong forces of attraction called hydrogen bonds. As a consequence, these solids have high melting points among the three types of molecular solids. Like the other two types of molecular solids, these solids are also non-conductors of electricity. At room temperature and normal atmospheric pressure, these are either soft solids or highly volatile liquids. The other type of crystalline solids is ionic solids. These solids have the ions as their constituent particles. The Coulombic or electrostatic forces of attraction hold the ions, cations, and anions together in the crystal. These cations and anions arrange regularly in three-dimensional space to form ionic solids such as sodium chloride, cesium chloride, and zinc sulfide. These solids have high melting and boiling points. This is attributed to the strong electrostatic forces of attraction. As a result, these solids are also hard but brittle. As the ions are in fixed positions, they are non-conductors of electricity in solid state. However, they are good conductors of electricity in fused or in their aqueous solutions. This stems from the fact that the ions acquire freedom of movement in their fused or aqueous solutions. You have now reached the end of this module. In this module, you learned that on the basis of the type of forces holding the constituent particles together, crystalline solids are broadly classified into molecular solids, ionic solids, metallic solids, and covalent or network solids. Solid helium, solid argon, solid neon, solid dihydrogen, solid carbon dioxide, iodine, and carbon tetrachloride are some examples of non-polar molecular solids. Non-polar molecular solids have low melting and boiling points and are non-conductors of electricity. Solid sulfur dioxide and solid hydrochloric acid are examples of polar molecular solids. Polar molecular solids have relatively high melting and boiling as when compared to non-polar molecular solids and are non-conductors of electricity. Ice and solid hydrofluoric acid are hydrogen-bonded molecular solids. Hydrogen-bonded molecular solids have high melting points and are non-conductors of electricity. Ionic solids have high melting and boiling points and are hard but brittle. Ionic solids are non-conductors of electricity in solid state, but good conductors of electricity in fused state or in aqueous solutions.